Unit 8.3, we're talking about graphing exponential functions again, but we're talking about what it is like in the real world. Okay, I know I have some people that can read and have nice voices. Can I get somebody to read this top portion here about the graphs? All right, Anthony, thank you.
Many real-world phenomenon can be modeled by functions that describe how things grow or decay as time passes. Examples of such phenomenon include studies of pollutions, bacteria, radioactive substances, electricity, and temperatures.
Do that next sentence too.
Any quality that grows or decays by a fixed percent at irregular intervals is said to possess exponential growth or exponential decay.
So how many of you, like in your biology classes and stuff, have talked about this kind of stuff? Okay, so anyways, so there is exponential growth and decay. So we're going to read through some of these problems here. Okay, so what is really nice about these problems is that they pretty much always give you the equation, and they also tell you what everything means. Okay? All you're doing is plugging in numbers and finding out what's missing. So let's go ahead and read through this. It says, when a plant or animal dies, it stops acquiring carbon-14 from the atmosphere. Carbon-14 decays over time with a half-life of 5,730 years. Right there, it just told you half-life, okay? Do you see where half-life is in your equation? It's right here for H. Okay. It says how much of a 10 milligram sample will remain after 22,920 years. Okay. So now we're going to plug this stuff in. Use this formula, and it tells you that n sub 0 is the initial amount. In the equation, who can tell me what the initial amount was? Very good, 10 milligram sample. So my n sub 0 value is 10. Next I have 1/2, and then T stands for time in years. So how many years? Very good, 22,920 divided by the half-life, which is?
5,007.
That is correct. Okay, who knows what we need to do first in this type of equation?
Do the fraction first?
Yeah, well, so you're going to want to do the exponent first, but I'm not really sure what that exponent is. So we're going to simplify that. So in your calculator, you can take and do 22,920 divided by 5,730, and we get 4. So this right here reduces to 4. Okay, so for a popsicle stick, I want to know what would be my next step in this problem. Eddie.
Right. I have no idea.
PEMDAS. What does PEMDAS say?
Oh, parentheses.
Okay, so parentheses are already simplified.
Exponents.
Exponents. Good. So my next step is exponents. Good. So 1/2 to the 4th power. How is that going to simplify? So we're still going to have our 10 times 1 to the 4th power is 1 over 2 to the 4th power is 16. You realize that everything we've been learning this unit, see how it's building? Like we need to know how to do our exponent equations in order to do these problems. Okay, so now I have 10 times 1 over 16. I can write 10 over 1, and then can you reduce this before you multiply?
Yes.
Okay, so 2 goes into 10. 5 times 2 goes into 16. 8 times you multiply tops with tops, bottoms with bottoms, and so we end up with 5 over 8 as our answer. Okay. Questions on this example?
Now I see where
Get away from chemistry.
All right.
Steven, you didn't take that long.
Example 2. We're going to practice, okay? So we're going to do this one together, and then you're going to try the next one on your own. So, one certain element decays over time with a half-life of 800 years. Notice how I would use a highlighter, circle, underline, all the important stuff, okay, so that you can go back and find it. Use the formula to determine how many grams will remain after 320 years. Make sure you're putting like what is with those things. 320 years if 500 grams were present originally. Okay? So, now we're going to use our formula and plug stuff in. A is the number of grams present originally. What number is that back in our 500? Very good. 1/2 stays there. T, time in years that has passed. How many times in years has passed?
Yeah, 3,200.
3,200. So pay attention because you'd have 2 different year terms. One is your half-life in years, and then one is just how many years have passed. So make sure you don't mix those up because you'll get a different answer based on how you write those. Okay, so our time is actually 3,200 divided by 800. Okay, so in this problem, my first step for a popsicle stick, my first step is what, Michelle? Very good. And what does that reduce to? Do you know? 4 is correct. I can cross out 0 for 0 when you have zeros, and then 32 divided by 8 is just 4. Okay, my next step in this equation, I need to do what? Caitlin. Very good. Exponents. And 1/2 to the 4th power becomes what? Anybody? 1/16 is correct. 2 to the 4th power is 16. 1 to the 4th is 1. Okay? Then I can write 500 over 1. And can I reduce?
Yes.
Okay, so I can divide by
2.
2. If I divide by 2, I get 8 and 250.
You get reduced again.
Can I reduce again?
Yeah.
By 2 again?
Yeah.
Or 4? 2?
4.
4?
Yeah.
Okay, I don't know why I can't think today. Okay, so nope, just 2.
Oh,
Okay, 2 to 50 divided by 2 is 125, and 8 divided by 2 is 4. So we end up with 125 over 4, or you can go ahead and give your 120 divided by 4, 125 divided by 4 in your calculator, and I get 31.25. So either one of these, actually it's not approximately, it's equal. Either one of those answers is correct. Does anybody know what actually is being, what this is? This is saying, this answer, what should I put for my units?
Grams?
Yes, grams is correct. Because it's saying 500 grams were present originally, and then after all of this time, now there's 31.25 grams present. Okay? All right, example 3. Let's see if you guys can get this one on your own. The first 3 people that get it correct will get a candy. Number 3, get the answer.
After 1 week? After 1 week. 1 week.
Okay.
Stressing out, baby. Ah. Oh, wait. No.
Is that your answer? I don't know, let's see if you set up. You would change it to an improper fraction.
Answer 75.
Yes.
How many grams are in an ounce? Okay, so.
I always have to go to my
Oh, yeah.
Okay. You guys are good. All right, I gave you a tough one. Okay.
I'm good at Half-Life, so that's the only thing I can do.
The radioactive gas radon, am I saying that right?
Right on. No, it's radon. I don't know.
Okay. Has a half-life of approximately 3.5 days. About how much of a 300-gram sample will remain after 1 week? I think that should say 1 week. Remember to convert 1 week to days.
7 days.
Good. Because see how it says time and days that has passed? You need to pay attention to stuff like that. So we can actually, if you want to, I might go back here so I don't confuse myself and put 7 days. Okay? Also, when you see a mixed number like this, I would either change it to a decimal or a mixed fraction. I'm going to change it, or not mixed fraction, an improper fraction. So 3.5 is the same as what as an improper fraction?
3.5.
As an improper fraction.
Wait. Oh, my bad.
7 over 2. I thought I heard someone say it, but maybe not. Okay, so 3 times 2 is 6, plus 1 is 7. So 7 over 2 is the same as that. So when we go through and plug stuff in, what is my A value? What is my initial?
300 grams.
300, good. Times 1/2. And then time in days would be?
So time would be 3 or 7.
7.
Yeah.
Divided by my half-life, we're going to write it as 7 over 2. That's what I would do. How do I get rid of a fraction over a fraction?
Just cancel.
Multiply by the reciprocal. So I'm going to multiply by 2 over 7 to both the top and the bottom. So the bottom cancels out. On the top, I have 7 or 7 over 1. So what ends up happening there? The 7's cancel out, and you're just left with 2. So now I do 1/2 to the second power, which makes what? 1/4. And we have 300 times 1/4, which ends up becoming 75 what?
Grams.
Grams. Okay. Okay, Geekonium. I'm pretty sure a lot of you have that one. Just kidding. Decays using this formula.
I see what you did there.
I think I'm funny. Other people, maybe
You're
not so
You're
much.
hilarious.
Okay, thank you. The half-life of Geekonium 25 is 2 years. Okay, so it's telling you half-life is 2 years. Find out how much of a 240-gram sample remains after 4 years. Now let's double check. Time, make sure that time matches. So this says time in years, this says years, we're good. Okay? So here's my equation. What is my initial amount? Very good. So we have 240 times 2, and then it's this one. Notice that the exponent is negative. Okay, negative, and then what is my t value? T is 4, divided by my half-life, which is 2. Okay? And
The formula is different.
good, because you remember how when we are doing our exponential, there is whole numbers and there are fractions.
Oh,
Okay? So there's growth and there's decay as well. Okay, so anyways, negative 4 over 2 reduces to negative 2. And what do I do with a negative exponent? Move it to the bottom. So I'm going to have 240 times, it's going to end up being 1/2 to the second power, because we had to flip it. or you can put 1 over 2, whatever. Anyways, we'll end up getting 240 times 1/4, which will then reduce to 60, and it's grams.